All right, welcome back to the second part of the video for vector applications, and we are starting this video with example 3 from our notes. All right, here we go. Number 3, we have an airplane that's flying north at 500 miles an hour when a wind of 20 miles an hour comes out of the east. What are the new speed and direction of the plane if no correction is made for the wind? So we do not try to stay on our path. We actually just let the wind blow us however we go. All right, so think about the way that the plane is traveling to start with, okay? So at the very beginning, it first says that the plane is flying north at 500 miles an hour. Okay, cool. So it's just going due north, 500 miles an hour. So its component form would be 0, 500. It's not going east or west. All right. The next part says a wind comes out of the east at 20 miles an hour. So here's our wind. It's coming out of the east. So it's starting on the right side and moving to the left. So it's actually going west. If we're coming out of the east, you're going west. So if that's at 20 miles an hour, for that second part of that statement, we're actually going to have a horizontal component of -20 and a vertical of 0. Okay, so our next part is, all right, well, if we put them together, so if I add those two together, then we get component form of -20, 500. So I would take the northern traveling of the plane, move it westward because of the wind, and give me a resultant force going in that northwest direction. Okay, so this one just says, what are the new speed and direction? Well, speed just means to find your magnitude. Okay, so I need to find the magnitude, and then I need to find the direction, which means the angle. So super, super easy. Let's go ahead and call this vector V. Why not? So the resultant is the plane, so vector P plus the wind, vector W, gives us V, the sum of those two together. So if I want the magnitude of V, that's going to be the square root of this component form. -20 squared plus 500 squared. And that will give us, let's see, what does that give us? 500.4 miles per hour. So it doesn't change it too much, actually. Not too bad. All right, now to find our angle at which we're traveling. So here's the angle at which we're traveling. That's right, guys. Look at that. We're going to have to go back and use a reference angle. So our reference angle is going to be tangent inverse of the opposite over the hypotenuse. So tan inverse of -500 over 20, or 500 over -20 means the same thing. So that means our reference angle works out to be about 88 degrees. Okay, so coming backwards, it's 88 degrees. So our true direction angle, theta, is coming off of, we're in quadrant 2, so we're coming off of the x-axis from the left. So it's got to be 180 minus 88, which gives us 92 degrees. It doesn't actually ask for the direction. It just says, hey, what is that? What's the measure of the angle for that one? So there you go. All right, next one. We have yet another plane. And it says an airplane flies at 150 kilometers per hour heading 30 degrees south of east. A 50 kilometer per hour wind blows in the direction of 25 degrees south of west. Determine the ground speed and the direction of the plane. Okie dokie. So in this example, we've got two different parts. So the first plane is at 150 kilometers per hour heading 30 degrees south of east. Okay, here's the first one, south of east. So south of east, which means that is a direction angle, 30 degrees at that particular spot. So I'm coming off of really 360, right? Okay. So if I want to find sine and cosine of those components, the x and the y values, because we have that magnitude or that force, that speed, 150 kilometers per hour. Okay, so x is going to be the magnitude multiplied by cosine of 30 degrees. We can totes do that. And that's going to give us 129.9. Okay, and then when we do our y value, we're solving for sine. So that's going to be 150 multiplied by sine of 30, which is going to give us a negative 75. All right, so now we know components of the first one. Negative 75, oh, excuse me, I wrote that in the wrong spot. The horizontal component is 129.9, and our vertical component is negative 75. Okay, so that's for the first part. All right, then it says a wind, so our first one was the plane, and our second part is for the wind. So the wind is 50 kilometers per hour at 25 degrees south of west. Again, that is another direction angle. So south of west, which means I need to travel west and then go south. So west and then go south. There's my vector at, let's see, what was that one, 50. And in this case, they told us that it had a 25 degree angle. So 25 degrees is right here. Cool. And again, we want our x and our y values. All right, so same stuff that we just did in the previous one. X is going to be the magnitude multiplied by cosine of 25, which will give us 45.3. And then the y value is going to be the magnitude multiplied by sine of 25. And that will give us 21.1. Okay, now the biggest difference here is because of the quadrant that I'm in, I actually got positive values for the horizontal and vertical components, but we have to change them to be negative because we're in quadrant 3. It says we went southwest, that's quadrant 3. So you need to change these components to be negative values. Okie dokie. All right, so what does it ask? Determine the ground speed and direction of the plane. So what we need to do here is to determine the resultant. So add those two vectors together and you will get a resultant of 84.6 comma negative 96.1. Okay, there we go, because those are both negative, so when I add them, when I determine the magnitude of the resultant, that's going to give me the speed of the plane. So the square root of 84.6 squared plus negative 96.1 squared. So we're going to determine that this has a speed of 128 miles per hour. All right, now here's the next part. When we do tangent inverse, okay, so we're still going to find that angle measure. So tangent inverse is negative 96.1 over 84.6. When we type that into the calculator, we get negative 48.6 degrees. Okay, that's not truly the angle that we want. So let's revisualize this. All right, here we go. We have the plane going southeast. The wind moves it southwest. So southwest for the wind, okay? Which means the resultant starts at the origin and does end up here. So this is our R value. Okie dokie. So the angle that we actually determined, excuse me, is coming negative 48.6. So it is coming from starting from one end to the other side. So I've got a negative 48.6 degrees here, which means that the entire angle is going the other direction. So 180 minus the 48.6 is going to give us 131.4. Okay, both of those answers are fine. You just need to give me the direction that they're traveling. So I personally like to go with the one that we got from tangent inverse. You just have to make sense of it. Okay, so think about your resultant vector. It's going southwest, right? So we are going to say it's 48.6 south of west. Now, you could give me the 131.4 and tell me that as well in respect to what we have, but I think it's easier to do this way. All right, that one was kind of a doozy, that last little part. We might need to think on that, so pause, rewind, replay, do what you got to do. Make sure you ask me questions if you need. All right, our last one, unfortunately, we have a car accident. Oh, darn. Police officers investigating an automobile accident. A car slid off of an icy road at a 40-degree angle with the center line of the road. So the median, like think about, or just, no, sorry, not the median, the center line. It is what it is, sorry. And it had an initial velocity of 47 miles per hour. So they're traveling down this road and they went, oh, dang, and they crashed the car. Now they're going 47 miles per hour at that angle of 40 degrees. Determine initial horizontal and vertical components of the car's velocity. So how far horizontally and vertically, like what was the speed originally before they had their accident? All right, so let's take our picture and kind of make sense of it. So here's my center line. We're going to call that the y-axis. And the car moved 40 degrees off of that particular center line. So that means my 40 degrees is actually the bearing because it's hovering on that north-south line. So then our actual direction angle, because it's a right angle in quadrant 1, is going to be 90 minus the 40, which is 50 degrees. We do know the magnitude or the speed of the car to be 47 miles per hour. And then this one's really, really simple. We're back to the basics, gang. Like I want the horizontal X value and the vertical Y value. So again, those are our ratios for sine and cosine. X is going to be the magnitude multiplied by cosine of the angle. So 47 multiplied by cosine of 50, which gives us 30.2 miles per hour. And then our vertical component, the y, sine, so it's going to be the magnitude multiplied by sine of the angle, 47 times sine of 50, and that gives us 36 miles per hour. So we ended on an easy note. That was pretty easy for us. We appreciate that. So we get 30.2 miles an hour horizontally, 36 miles an hour vertically. And those would be your components if you were to write it in component form. Thanks for sticking with me for another 13-14 minutes for these other examples. You got a ton in your vector unit packet that you can work through and kind of process through. Just do a little at a time. Get your feet wet with them and keep trying your best. Have a good one. See you guys later.